Har vi en wrap-up också i slutet, men på det här spåret är det Lena. Och jag tror Lena är med oss, va?
Jajamän, det är jag.
Titta, där är du. Vad kul att se dig.
Detsamma, det var länge sedan.
Det var det. Det är ofta så i såna här sammanhang. Men jag har sett dig i diverse chattar fladdra förbi. Så det känns som vi pratar oftare om vad vi faktiskt gör. Ja, igår råkade jag skicka en arg gubbe fast jag var jätteglad. Sånt kan ju hända när man bara chattar och inte syns. Men kommunicera kan vara svårt när man är till för varandra. Men du har ju lyxen att jobba på, antar jag liksom i alla fall, på ett ställe som jobbar väldigt mycket. Vi ska kunna kommunicera och lite mer interaktivt även i dessa tider.
Precis.
Så varsågod och dela din historia.
Ja, men tack. Då ska vi se att vi får allting att funka. Förhoppningsvis så ser ni slides nu och inte mina speaker notes.
Vi ser slides precis som de borde se ut, tror jag.
Cool. And I promise to do this in English, so I'm going to switch to English. So, thank you so much for having me here today. I'm going to continue on some of the themes actually from Pablo's presentation and tie back into that, but with another angle to it. So I'm going to talk about delivering fast and slow and ethics around software development. So since I thought I had 40 minutes, but I only have about 30, I'm going to skip a bit, but very, very shortly about me. I am a developer who turned tester, who turned manager. So one of the people Pablo was talking about, but hopefully not with the narcissist disorder. When I don't work as a manager, I also do a lot of speaking, workshop facilitation. And I also, as Jonas mentioned, I am engineering manager at Mentimeter, a company I hope most of you have heard about. And we work with an interactive presentation platform with the goal of making everybody's voice heard. So to set the scene about ethics and things we need to consider building software, I want to share imaginary story about an imaginary team. We can call them Team Awesome. Team Awesome consists of Ian, our junior developer. He just started in the team and he is very scared to lose his job because he's still on his 6 months probation period. We also have Sam, who is our senior tech-savvy coder, loves to try out new things, try out new tools, new frameworks. We have Alex, who is our business analyst. He's very, very engaged, very enthusiastic, and he likes to pair up with different people in the team to kind of tweak the requirements all the time. We have Morgan. Morgan is our tester, and Morgan has the viewpoint that testing should not be a gatekeeper. Testing should be an information provider. So basically, I don't make decision. I just give information to shareholders, and then the shareholders can decide what to do with it. We have Kim, our project manager. Kim is really kind of my all of my prejudice around project managers. The born risk taker. Goes by the motto, I would rather ask for forgiveness than approval. And then we have, on kind of the sidelines, Chris, who is our customer in this case. So I'm going to tell you about a chain of situations that happened in this team and the result of it. So it all starts out with Sam. As I mentioned, Sam really, really likes to try out new things. So Sam picks up a feature that allows her to try out a new tool. She gets really caught up in this implementation, and unfortunately it doesn't go as she hopes. So she ends up with too little time. So in the end, she has to do kind of a quick and dirty solution, which ends with some technical debt. because in the end, we really needed this framework to move forward. But it's not implemented in the best way possible. Sam and Alex, they pair up a lot. So around one feature, Alex and Sam, they sit down and they discuss different ways of solving the problem, and they agree on changing little tiny things in the requirements to build what they believe is a better solution. So they come from the agile mindset of human interactions over documentation. So they do pairing, but they don't document the changes they make. And unfortunately, they also don't inform the rest of the team of the changes they have made. Which of course results in different people in this team having different views on how this feature actually should work and does work. And then we have Ian. As I mentioned, Ian is new to the team. Ian is still on his probation period, so he's really, really scared of losing his job. He's also he doesn't feel safe in speaking up in the team. So he gets a feature and he doesn't really understand the story, but he's not comfortable enough to say it out loud. He's afraid of losing face with the team, but he's also afraid of actually losing his job. So as a consequence, we have an implementation that is off from what it's supposed to be. Morgan is testing this feature, and while Morgan is testing it, he comes across a potential bug. It's an edge case, and he's a bit unsure about how it's actually supposed to work. And Morgan shares this information with the people he believes are in charge, and gets convinced to not report this potential risk. As I mentioned, Morgan believes that he's only a provider of information and someone else decides what to do with it. So he was only following orders. In this case, a bad bug doesn't get fixed and also doesn't get reported. Which leads us to Kim, our project manager, who was the one convincing Morgan not to report this potential problem. From Kim's point of view, this was a reasonable decision because it was very unlikely. It was agreed upon between the two of them that it was very improbable that this would be a real bug. And from Kim's point of view, a delay of this project could cost too much. It could actually mean so much that the company would have to let go of a number of people if this project is not delivered on time. So Kim decides that we don't report this, we hide this from the board so we can move forward with the project. And of course, this means that this bad bug actually goes into production. But we still have one person left in the team, and that's Chris, our customer, our user. Unfortunately, this bug happened to be security related, which means that Chris's data is accessed by people who shouldn't have access to it. So the data is leaked. And of course, as we all know, we know how we're supposed to use our user data. We're supposed to use different passwords for different sites. We're supposed to store it safely and all of these things. But of course, we have users like Chris. So Chris is, of course, reusing username and password on different sites. And as a result, Chris's identity is unfortunately stolen. And this is a scenario in a team I just dreamed up. But to be honest, things like this happen all the time. Small decisions that seemed harmless at the time end up as really big problems in the end. So to set the scene a bit more, I'm going to talk about what is the worst that can happen. I'm going to pick some examples that are a bit over the top, but it's just to show you what is actually the worst thing that can happen. And to start off, one of the worst software failures I can think of is the Boeing 737 MAX 8S. If you're unfamiliar with it, in 2018 and 2019, 2 airplanes crashed, leaving more than 300 people dead. And to understand why this happened, we have to move back all the way to 2010, so almost 10 years before. Because that year, Airbus announced that they were making a new airplane model that was more fuel and cost effective. So of course, Boeing panicked and they were like, we need to do something. So they decided to take their very famous and popular Boeing 737 and make a new model. And to simplify the scenario, in order to increase fuel efficiency, they made the engines larger. And when they made the engines larger, they became heavier, so they had to move them forward and higher up on the wings. And when they moved them forward and higher up on the wings, the plane got unbalanced and the nose tended to kind of pitch up during flight. So how do we solve this? Of course, we solve it by software. So they built something called the MCAS, Maneuvering Characteristics Augmentation System, with the sole purpose of having 2 sensors that read the angle between those 2 sensors. And if the angle is too steep, the MCAS system will try to push the nose downwards. Okay, so what actually happened in the crash? Well, it started out with these sensors malfunctioning. So the sensors told the plane that the plane was stalling when it actually wasn't. And this triggered the MCAS system, and the system did what it was told. It tried to push the nose down. And also this happens automatically, which took the pilots totally off guard, because to add to injury, the pilots were not trained on this new model, because the association regulating this decided that they had so much training on the old Boeing 737, so they didn't need new training. Adding a bit more, there was a warning light indicating that these sensors were faulty, but Boeing decided that this should not be included as a standard, so it was an optional buy, which of course means that the clients didn't buy it, because then the planes were cheaper. Digging into this, there's a lot of additional bad decisions taken in this. So we have the Federal Airline Association who pushed their the engineers who approve different new airplane models. They pushed them to approve the permits. And they did this even though the actual safety assessment was filled with errors from start to end. All of these decisions probably seemed pretty small and harmless at the time, and reasonable, but they ended in 300 plus people dying out of a malfunctioning sensor. And of course, not to only put blame on Boeing, Airbus also has issues. My favorite example is an internal timer that's slightly off in one version of an Airbus model. And this requires a reboot every 6 days. This was around for years, but it was too costly to update the software, so it was cheaper to just reboot the software every 6 days. Okay, airplanes, but we also have the Mars Climate Orbiter, where NASA used metric system in one part of the software and Lockheed Martin used the imperial system in another part of the software. So the calculations, although they were correct, they were using different systems, which of course meant that the orbiter got too close to the atmosphere and was either destroyed or lost in space, we don't know. As testers, we know that we often speak up about problems, and this happened in the Mars Climate Orbiter case as well. There were at least 2 people who actually tried to tell people that there was an offset in the trajectories, but they were ignored because they didn't follow the correct documentation procedure. So that's about $450 million just lost in space, literally lost in space. We have our healthcare. There was an incident in 2017 where a very simple journaling system, I mean, this is basically a word pad, but for hospital systems. It couldn't handle Swedish characters, which meant that during a routine examination, the patient got ill, it fainted, and when the staff started taking notes, they used the Swedish character Å, which meant that the blood pressure and heartbeat machines froze. In this case, nobody died. The worst thing that happened here is that the patient might have to retake the examination. But imagine if this had been in a situation where keeping track of the blood pressure and heartbeat was actually the thing keeping someone alive. In this case, it wasn't even a software malfunction. It was the fact that they have bought this system from the United States, I believe, and they didn't handle non-American character sets. So hopefully not all of us work with airplanes and X-ray machines or things where people actually die. But I just want to set the scene about why ethics is actually important to us. So I'm going to move on to talking about ethics for a bit. And I want to start out with the fact that we actually have a code of conduct that I believe not all of us know about. The Association for Computing Machinery has a big documentation around ethics and professional conduct. But I wanted to highlight this part. Computing professionals' actions change the world. So to act responsibly, they should reflect upon the wider impact of their work and constantly support the public good. Well, okay, seems like a large order to handle. So how can we do that? Well, I want to share with you 10 commandments for ethical techies, published originally by Fiona Charles from Quality Intelligence. And the first thing we need to do is understand our basic professional obligations. So basically, what is it you are hired to do and what is important? So as testers, it's probably to discover information and pass that information on to stakeholders, which means we are basically paid to tell the truth. And this is going to be important later on. We need to know our legal and contractual obligations. So one, what is it that's actually stated in your contract that you need to follow, but also what laws and regulations or standards are you actually expected to follow. So GDPR is a good example for us here in Sweden. We can't expect someone else to tell us all of these things. We need to actually know about the things that affect the software we're building. And then we need to know our own ethical bottom line. So this means, what is the line you are not prepared to cross? What are you prepared to do, and what will you never do? So a lot of people say, I would never lie. But how far will you take that? How small and white a lie are you prepared to risk your job for, basically? I would never falsify result. Well, okay. Is that true for every scenario out there? And you need to figure out for your own where your bottom line is. What are you prepared to risk everything for? We also need to understand whose interests are we really serving? So who are your truly important stakeholders? If you are building X-ray machines, that's probably doctors and patients rather than whoever's paying for building this software. If you're building a voting app, it's probably the voters and the government and not the consultancy firm who's building the software. We need to know what harm our software can do. So both in the sense of what's the worst harm it could do. Could someone actually die? Or is the worst thing that could do that someone's credit card account is stolen? But also, what's the likely harm it could do? And I mean, when I started out, this was pretty simple because you could actually understand all of the parts involved. But today we have so many algorithms and components and frameworks that we just don't know. We just use them, but we don't know how they actually work. We have machine learning algorithms that we don't understand what they actually do. We collect data and we spread it and we use it for monitoring and for analytics and for doing A/B testing. And do we know all of the places our data is used and how it can be misused? So, for example, did people understand Cambridge Analytica before Cambridge Analytica actually became a problem? We need to be aware of our whole work situation, and this means the application, the data, the ecosystem that the application exists in, but also things like what's the company's both open and hidden goals? What are they trying to achieve? So openly, Volkswagen didn't have a plan to hide carbon dioxide results. But what are they prepared to do for money or for fame or whatever's important to the company? We need to figure out what the company is actually about. And also keep aware of other ethical problems around us that could potentially relate to us, such as machine learning bias creating racist applications, or data bias, meaning that women are less likely to get hired for a position, or bias in how we do user personas. We need to be aware of all of these things. We need to be good at saying no. And as a parent, I can tell you, I wasn't aware of this before, but we really raise our kids to say yes. Be positive, to comply, to want to agree and do things. We as society avoid saying no if we can avoid it. But we need to learn how to say no. and also speaking truth to power. And I mean, as testers, that could be really hard because it's not very fun to always be the person who brings out risks and problems and what if, and this could happen. But we really need to learn it, even if it doesn't make us popular. We can't hide behind the "I only followed orders" thing. It's not ethical. And in order to do all this, we need to really know how to escalate things. So if we raise an issue and we are told not to report it or not to act on it, if it's really, really important, we need to know how to escalate that. Could be to the project manager's manager or to our manager's manager, but it could also be someone on the sidelines with less stakes in whatever question is on topic. We need to both know our ethical bottom line, but also know our tolerance for personal risk and career risk. So before we raise this issue or escalate it, we need to think about, so what's the real risk behind doing this? What's the risk to you, but also what's the risk to someone else? So if I am uncomfortable, what am I risking? Am I risking my job? Am I risking my professional reputation? Am I risking someone else's life by doing this? And then, of course, compare that to what's the risk of not doing this? What's the worst thing that can happen if I don't fight for this issue and it turns out to happen? And then we need to decide, so am I in a place where my risk tolerance with the potential risk to happen, where are they balanced? Or if I can't afford losing my job, but the worst thing that could happen is that 300 people die, maybe that's not a position I can be in because it will force me to make unethical decisions. So those were 10, and Fiona also has a bonus, which is document your concerns. So keep a paper trail, people. And when I send out these slides, I encourage you to take this slide, print it, and put it somewhere where you can watch it all the time, because I feel these are the commandments I live by and not the commandments from the Bible. Okay, so I have about 8 minutes left and I want to talk a bit. I want to move back to the part about delivering faster, cheaper, deliver more, need to be more agile. So there is a book called Thinking Fast and Slow by Daniel Kahneman, which talks about two systems basically ruling us as humans. We have one system that's automatic, fast, impulsive, it's energy efficient, it's also judgmental, it relies on intuition, it makes assumptions. Basically, it thinks it can handle things even when it actually can't. This is the system that's if you, for example, you've been driving the same road forever and ever, and you just zone out and you just drive on automatic. You're honestly very, very certainly using system 1. Or if someone scares you and you jump away, you're using system 1. System 2 is conscious and aware and considerate, but is also slow and costs a lot of energy, and we just can't spend all of our time in system 2 because we would be exhausted after an hour. So we avoid using it if we can. But say that you're asked to calculate a complicated algorithm, system 2 is connected. So why is this relevant? Well, when we remove all the friction, when we deliver faster and faster and faster and faster, we use more and more of system 1 because we don't have time or energy to connect system too. And sometimes we actually need to stop and think about things before we move on. So, as Pablo mentioned, Agile is good. It's really good if you use it for the right reasons. So we want small changes mean small risk. We want fast feedback change. We want to try things and see that they work before we build large things. So we want to fail fast and carry on. But I think I'm not the only one who has seen Agile being used as a way of delivering more and cutting costs. And we need to be on the lookout for when people are pushing us to deliver faster because they want to save money, rather than the reasons that are the reasons we actually should deliver faster. Cross-functionality can be awesome. I mean, if we have someone who can do all the things, that's amazing. But if you're building a house, you don't want a Swiss Army knife. You want a toolbox of things that are doing the job in the best way possible. And finding this balance can be really, really hard. But I just want you to bring with you that Agile says cross-functional team. It doesn't say that every individual should be able to do all the things. So figure out the sweet spot between having 10 million people specialized in one tiny little thing, or having 4 people who have to know how to do all of the things, but don't do it good. Because all of this context shifting, it removes flow and it takes energy to do the switch. So maybe doing all of this context switching isn't actually speeding you up. It might be slowing you down and spending energy in the wrong place. Another aspect is we need to balance mastery versus speed. So I mentioned all of these black box algorithms and frameworks. And I mean, it's amazing building software today because there are so many puzzle pieces. You just, like Lego blocks, you just pick from the internet and you put them together and you build very, very technically complicated things very, very fast. But it also means that people not always understand what it is they're actually building. So balance that mastery and speed. And I think I'm behind. So I'm gonna quickly switch to the summary. If you take anything with you, these summary slides are what I want you to bring with you. So it is usually not one big bad decision that caused the plane to crash. It's a number of small ones that together cause the catastrophe. Make sure you're fast or slow for the right reasons. We shouldn't introduce friction just to slow things down or because we're scared, but we shouldn't be fast just to save money. Figure out your bottom line. What are you not prepared to cross? And when you make bad decisions, never blame them on someone else. And also don't pressure others into making bad decisions. It should be obvious, but I see it happening all the time. Because you are responsible for your choices. But I believe you're also responsible for calling out other people's bad decisions if you see them. Because we all take liberties with the truth at times. We tell white lies. I don't think I've ever met anyone who never, ever told a lie. And it could be for good reasons. It could be, we believe standing up to someone will cause more harm than we will gain. It could be we withhold information to protect someone. Or it could be, if I tell management all of the truth, they will just not allow me to do something. And it is easier to beg for forgiveness. It could be fear. It could be you want to gain something. So you are constantly making risk assessment and choosing whether to tell the whole truth or parts of the truth or lie. And some of those choices will be wrong. So make sure the decisions you make that are wrong won't cause 300 people to die in a plane crash. Thank you.
Tack. Väldigt, väldigt intressant och lärorikt. Jag tror jag har hört något liknande från dig förut, men den är ännu intressantare andra gånger man hör. Du kanske har lagt till ännu mer visdom i den. Vi har tid för ett par frågor.
Alla sitter och gråter av rädsla för att planet ska krascha nu. Förlåt.
Ja, lite så. Det brukar ta ett tag innan folk kommer igång att unmuta sig för att ställa frågor eller skriva i chatten. Annika tyckte det var mycket tänkvärt. Bra. Hej Annika förresten, det var länge sedan. Den meningen jag sagt några gånger idag kan vara corona-effekten som gör att det är så. Ja, du hade dina kontaktuppgifter där så att folk får kontakta dig när de undrar och vill saker helt enkelt.
Absolut.
Jättestort tack. Det var det sista på det här spåret för idag. Så, förlåt. Nu fick jag fick en teaterviskning som jag råkade muta bort så att inte ni hörde den också. Men i spår 1 så körs det en wrap-up av det här som börjar nu om 2 minuter. Som sammanfattar konferensen och någonting. Så då behöver ni helt enkelt byta Zoom-länk från den ni är inne på nu till den som finns på spår 1. Om ni går in på SAST hemsida så finns det även en länk längst ner där som heter wrap-up som ni kan gå in på. Men vi tackar så hemskt mycket från Ideal-spåret och väldigt tacksamma att vi faktiskt har legat och slagit i taket hela tiden på antalet deltagare.
Ja, jag tror det finns en fråga från Eva Lin. There's a question from Eva Lin, I think in the chat.
Ja, Eva, jag tror att den är lite för lång och svår för att svara på 2 minuter. Jag har jättemånga exempel där jag har behövt göra svåra beslut. Skulle kunna skriva en hel bok om det, men jag har till exempel lämnat företag för att jag inte kan stå bakom hur man väljer att bygga system.
Bra. Tack för det allihopa. Inspelning på det här kommer läggas ut på YouTube så småningom när Zoom brukar vara bra på att stå och processa ganska länge efter sådana här långa. Men när det väl är gjort så kommer det hamna på YouTube. Jag gissar att länkarna kommer att finnas från den här sidan på SAST hemsida. Skulle jag gissa på i varje fall. Men det är Jörgen Damberg som har den fina uppgiften tror jag att lägga ut. Men tack så mycket så syns vi på wrap-upen. Hej då!